From X-rays to nuclear power, we have all heard of radioactivity and radiation before. But why are some elements, such as uranium, more radioactive than the others? In this video, we will go over what radioactivity is, what makes some elements radioactive, and half-life. To start, what even is radioactivity anyways? To put simply, radioactivity is the natural process of an unstable atom becoming a stable one by releasing particles and energy. Some atoms are made with a different number of neutrons than they are supposed to, and they are known as isotopes. For example, a carbon atom will normally have 6 protons and 6 neutrons. We know this because its atomic number is 6, which means that it has 6 protons. Its atomic mass is 12, so it must have 6 neutrons, since 12 minus 6 is 6. However, there exist carbon atoms with 8 neutrons instead, making their atomic mass 14. They are considered isotopes of carbon, and we refer to them as carbon-14. It is very unstable and thus radioactive, as it wants to shoot out the extra neutrons and energy to become the normal carbon atoms with 6 neutrons. This property actually helps us with carbon dating, but I will cover it in another video. Some elements are unstable by themselves too, not just their isotopes. Uranium is an element that is unstable to begin with, and is quote-unquote born unstable. This is why we associate uranium with radioactivity. It literally is always unstable. Not all isotopes are unstable, however. Take oxygen-18 for example. Even though oxygen normally has 8 protons and 8 neutrons, oxygen-18 has 8 protons and 10 neutrons, but it is still stable, so it is not radioactive. So now, how do unstable atoms make themselves radioactive? As I mentioned earlier, those unstable atoms want to somehow become stable, by somehow getting rid of their particles and energy. There are 3 main ways to do this: alpha decay, beta decay, and gamma decay. Starting off with alpha decay, it is when an atom releases an alpha particle, which is made of 2 protons and 2 neutrons, same as the nucleus of a helium atom. Alpha decay occurs in heavier elements, so take uranium for example, with a mass of 238 with 92 protons and 146 neutrons. When it undergoes alpha decay, it loses 2 protons and 2 neutrons, making it into an atom with a mass of 234, with 90 protons and 144 neutrons. Which means, when uranium undergoes alpha decay, it emits an alpha particle and becomes thorium-234, which is still an unstable and radioactive element that will undergo decay again until it reaches a stable element. Next, we have beta decay, which is when an element emits a beta particle, which is a particle of a -1 charge, sort of like an electron. Beta particles are released by neutrons so that they can become a proton, since losing a negative charge means becoming 1 charge more positive. For example, when thorium-234, with 90 protons and 144 neutrons, undergoes beta decay, an electron is emitted, while one of the neutrons become a proton. This creates an atom with a mass of 234 still, but with 91 protons and 143 neutrons, making it protactinium-234, which is still radioactive. This cycle continues until the atom reaches lead-206, which will finally be stable. Lastly, we have gamma decay, which releases gamma particles, which are just high-energy protons in the form of gamma rays, usually released alongside alpha and beta particles. Gamma particles are quite dangerous, as gamma rays can easily damage DNA and body tissues. Finally, we'll briefly touch on half-life, which is just how much time it takes for half of a radioactive element to decay. Uranium atoms have a half-life of 4.5 billion years, so it will take 10 grams of uranium atoms 4.5 billion years to become 5 grams. This means that the longer the half-life, the safer an atom is in terms of radioactivity, since it takes longer for the atom to emit all those harmful gamma rays. In contrast, polonium is a radioactive element with the half-life of 138 days, making it the most radioactive element in the world. And there we have it. Radiation is caused by unstable atoms wanting to become more stable, by emitting alpha particles, beta particles, and gamma particles, the latter of which is extremely harmful. Many of the unstable isotopes and elements occur naturally, and their half-life tells us how much time it will take them to become half as unstable. I hope that y'all have learned something interesting today. Thank you for watching, and good luck with everything!